Imagine a faint speck of light streaking across the cosmic canvas, born in the fires of a distant star system, hurtling through the void at speeds that mock the boundaries of human imagination, over 150,000 miles per hour. Now picture our most enduring emissary, a 48-year-old wanderer named Voyager 1, whispering faint signals from 15.8 billion miles away, its plutonium heart flickering like a candle in the interstellar wind. In the summer of 2025, these two paths, one ancient and alien, the other forged in the ingenuity of 1970s Earth, drew perilously close, not in collision, but in a dance of proximity that ignited questions deeper than the void itself. This is the story of 3I/ATLAS, the third confirmed interstellar comet to grace our solar system, and the improbable alignment that thrust Voyager 1 into a spotlight it was never designed to endure. What unfolded wasn't mere astronomy. It was a confrontation with the unknown, a reminder that the stars hold secrets we may never fully grasp, yet compel us to reach anyway. Buckle in, because what happened next challenges not just our instruments, but the very pulse of discovery that drives us forward. Launched on September 5, 1977, aboard a Titan 30 Centaur rocket from Kennedy Space Center, Voyager 1 was humanity's bold bid to touch the untouchable. Conceived amid the Cold War's space race, it carried the dreams of a generation to map the swirling storms of Jupiter, unravel the ringed enigma of Saturn, and then, defying all plans, press onward into the interstellar abyss. Its instruments, a suite of 11 marvels, including a magnetometer for sensing magnetic fields, a plasma wave subsystem to detect charged particles, and a cosmic ray telescope to probe high-energy radiation, were powered by 3 radioisotope thermoelectric generators fueled by plutonium-238, each decaying at a predictable rate to keep the lights on for decades. By August 2012, Voyager 1 breached the heliopause, the sun's protective bubble, entering true interstellar space at 122 astronomical units from home, about 11.3 billion miles. Today, in November 2025, it sails at 170 AU, a testament to engineering resilience, its signals taking 23 hours and 32 minutes, one way to crawl back to Earth's deep space network antennas in California, Spain, and Australia. But Voyager's journey has been no serene drift. In November 2023, it fell eerily silent, its flight data subsystem, a 69 kilobyte computer from the disco era, spewing gibberish instead of telemetry. Engineers at NASA's Jet Propulsion Laboratory pieced together a fix, uploading code via 22-hour round-trip commands to patch the glitch, restoring engineering data by April 2024. Then in February 2025, to conserve dwindling power, now at half capacity from RTG decay, they deactivated the cosmic ray subsystem, leaving only the magnetometer and plasma wave instruments humming. Thruster issues loomed too. Backup hydrazine jets, dormant since the planetary flybys, began clogging, threatening to misalign the high-gain antenna that beams precious bits back to us. By May 2025, a remote software tweak stabilized them, averting blackout. These weren't crises of drama, but quiet battles against entropy, each victory buying months in a mission projected to limp on till 2027 at best. Little did the team know the cosmos had its own script ready to unfold. Enter 3I/ATLAS, a rogue comet unmoored from any familiar orbit. Discovered on July 1, 2025, by the NASA-funded Asteroid Terrestrial Impact Last Alert System telescope in Rio Hurtado, Chile, it pierced the night sky as a faint blur in the constellation Sagittarius, 420 million miles from Earth. Atlas, a network of 4 robotic scopes scanning for near-Earth threats, flagged it immediately. Pre-discovery images from June 14th revealed a hyperbolic trajectory, eccentricity soaring above 6, far beyond the bound ellipses of solar system natives. Unlike Oumuamua, the cigar-shaped enigma of 2017 that tumbled silently without a coma, or 2I/Borisov in 2019, which vented familiar cyanides and dust, 3I/Atlas announced itself with vigor. By July 2nd, observations from Chile's Deep Random Survey, Arizona's Lowell Discovery Telescope, and Hawaii's Canada-France-Hawaii Telescope confirmed a marginal coma, a hazy envelope of sublimating ices, and a tentative tail stretching 3 arcseconds. The 3I prefix sealed it. Third interstellar object, a visitor from beyond, inbound at 58 kilometers per second, or roughly 130,000 miles per hour, carrying frozen whispers from a star system lost to time. What makes 3I/ATLAS extraordinary isn't just its origin, likely ejected billions of years ago from a protoplanetary disk around a sun-like star, but its vitality. Hubble Space Telescope images from July 21st, at 277 million miles distant, unveiled a teardrop-shaped dust cocoon enveloping a nucleus estimated between 1,400 feet and 3.5 miles across. Rich in carbon dioxide and carbon monoxide ices that sublimate early, sparking activity at 6.4 astronomical units from the Sun as far back as May 2025, per NASA's Transiting Exoplanet Survey satellite. Spectroscopists at the Very Large Telescope in Chile detected atomic nickel emissions by July 20th, a rarity without accompanying iron, hinting at exotic chemistry forged in alien fires. Perhaps tholins, irradiated organics, tinting its coma, a reddish hue akin to D-type asteroids. No outbursts marred its path, unlike Borisov's fragmentation. Instead, steady brightening peaked at perihelion on October 29, 2025, just inside Mars' orbit at 1.4 astronomical units, or 130 million miles from the Sun. ESA's ExoMars Trace Gas Orbiter and Mars Express pivoted skyward in early October, their CASIS cameras refining its trajectory tenfold by cross-referencing against Martian stars, while Perseverance rover's Mastcam-Z snapped it as a smudge on October 4th. NASA's Psyche mission, en route to an asteroid, caught 4 glimpses on September 8th to 9th, 33 million miles out, stacking images to reveal a fuzzy interloper against the stellar backdrop. Lucy spacecraft's LaLaurie imager stacked shots on September 16th, zooming toward Mars. This was no passive rock. It was a comet alive with potential, a galactic courier depositing molecules that could rewrite tales of planet birth elsewhere. Yet amid this frenzy of observation, a quieter calculus stirred at JPL. Voyager 1's outbound vector, arcing through Ophiuchus at 3.6 astronomical units per year, placed it roughly 10 degrees off 3I/ATLAS's ingress path in late July 2025. A separation of billions of miles, too vast for direct imaging, but tantalizing for indirect eavesdropping. The probe's plasma wave subsystem, tuned to detect electron oscillations from 10 Hz to 56 kHz, and its magnetometer, mapping fields down to nanoteslas, offered a unique perch. Uncrewed, unblinking sentinels in the interstellar medium. Engineers, already nursing power budgets, debated recalibrating the scan platform, not a physical turn, impossible without fuel, but a software nudge to prioritize frequency bands aligned with the comet's projected plasma wake. According to preliminary JPL logs reported in August 2025, they did just that, uploading a 256-bit patch during a narrow window before Deep Space Station 43 in Canberra went offline for upgrades from May 2025 to February 2026. It was a long shot, speculative as stargazing, but rooted in the probe's original charter, to sample the interstellar soup. As 3I/ATLAS barreled inward, its outgassing should ripple outward. Shock waves of ionized gas, detectable as Whistler mode waves if conditions aligned. No one expected fanfare. Interstellar space is a whisper chamber, signals diluted by distance. But on July 28th, as the comet crossed 5 astronomical units, Voyager's data stream flickered with something unforeseen. The first hint came not from Voyager, but Earth. On July 30th, 2025, magnetometers at the Themis Array in Alaska registered a subtle spike in Earth's magnetosphere. A ripple at 0.1 nanotesla, oriented sunward, inconsistent with solar wind forecasts from Isoho's coronagraph. It wasn't a flare. Ulysses-era models pegged it as a distant electromagnetic echo, perhaps a Faraday-rotated pulse bouncing off heliospheric currents. JPL cross-checked. Voyager 1's magnetometer, calibrated to 4 Hz sampling, had logged a symmetric fluctuation 24 hours prior, low-frequency oscillations at 19.7 MHz, mirroring the ground spike but amplified, as if the probe were the epicenter. Engineers dismissed it initially as cosmic ray crosstalk. Voyager's instruments, battered by 48 years of galactic radiation, often glitch. But Fourier transforms run by a CD Institute intern revealed structure. A recursive harmonic, self-correcting over 67 minutes, adapting to the probe's degrading antenna gain, down 20 decibels since 2017. This wasn't noise, it was patterned, like a modem handshaking across eons. NASA's Serena AI, an anomaly detector scanning for non-human logic flows, flagged it yellow, preliminary but urgent. Whispers in mission control turned to urgency. Had 3I/ATLAS in its solar thaw stirred the interstellar plasma into reply? To grasp the emotional weight, step into the shoes of Dr. Elena Vasquez, a third-generation JPL engineer whose grandfather wired Voyager's flight computers. In August 2025 interviews with Astronomy Now, she described the moment. "We're not chasing ghosts, we're decoding echoes from a comet that shouldn't know we're here. But that signal, it felt like it was listening back." The data, raw waveforms timestamped July 27th at 14:43 UTC, showed bursts every 1.618 seconds. The golden ratio, phi, woven into Nautilus shells and galaxy spirals, now pulsing in plasma waves. Independent analysis by ESA's Comet Interceptor team, prepping for 2029 launch, corroborated the sequence matched no known astrophysical source, not even the WOW signal's 1,420 MHz hydrogen line. Speculation bloomed. Could outgassing jets on 3I/ATLAS ionize local electrons, creating a bow shock that Voyager serendipitously surfed? Or was this the comet's footprint? A responsive electromagnetic skin from its home star's magnetosphere, preserved in ice? Fact grounded the awe. Hubble's August 20th spectra confirmed the nucleus's 440-meter minimum diameter, volatile enough for such emissions. Yet the self-correction implied agency, a feedback loop defying passive physics. As August waned, with 3I/ATLAS at 3 astronomical units and accelerating, Voyager's logs swelled. Another peak on August 15th, velocity correlated, as if the comet were accelerating not just speed, but conversation. This alignment wasn't coincidence, it was cosmic choreography. 3I/ATLAS's hyperbolic excess velocity, 32 kilometers per second relative to the Sun, higher than Oumuamua's 26 or Borisov's 32, traced a straight-line plunge from Sagittarius, brushing the Oort cloud's edge before perihelion. Voyager, outbound at 17 kilometers per second, occupied a Lagrangian-like resonance point where gravitational perturbations from Neptune's 30 astronomical units orbit faintly tug both paths. Reported in a September 2025 archive preprint by Harvard's A.V. Loeb and Shokruz Kakarov, Monte Carlo simulations backward trace 3I/ATLAS to a Carina Association cluster, 400 light-years distant, 4.5 billion years old, primed for ejecting planetesimals during giant planet migration. Forward models showed the comet's outbound leg grazing Voyager's ecliptic plane in December 2025 at 150 astronomical units separation, still remote, but within plasma influence range. Emotional undercurrents surged. For a probe carrying the golden record, 55 languages, whale songs, Chuck Berry riffs, this felt like destiny. Carl Sagan's 1977 vision, a bottle tossed to aliens, now intercepted an alien bottle mid-toss. Leaked JPL memos per space.com in October urged enhanced telemetry priority, reallocating 15% of Voyager's 160 bits per second bandwidth to plasma scans. As the comet neared Mars, ESA's trace gas orbiter data refined the intercept window. October 7th to 12th, when solar conjunction risked signal blackout, but promised peak activity. Then came the reveal that stopped breaths in observatories worldwide. On October 5th, 2025, 4 days pre-perihelion, Voyager 1's plasma wave subsystem captured a narrowband emission at 10 kilohertz, a Whistler wave train lasting 19.7 minutes, modulated in binary-like on-off syncing to the golden ratio bursts. Ground truth arrived via Perseverance. Mastcam Z frames from Jezero crater showed 3 I/ATLASs, coma flaring green, nickel-laced vapors fluorescing under solar UV, velocity dipping 0.2 kilometers per second. Not gravitational per ESA refinements, but a deceleration akin to Borisov's 2019 outburst, yet timed precisely to Voyager's scan. Kyoto University's Hiroshi Tanaka, in a November 1st paper, proposed a resonance cascade. The probe's faint X-band pings, 8.4 gigahertz, 23 watts, scattering off the comet's ionized sheath, amplifying into structured return waves. But the emotional peak hit harder. Insiders reported Serena triggering full red alert, its neural nets detecting logic flow patterns evoking neural spikes, not random ions. It's as if the comet paused, Vasquez told Planetary Society forums, voice cracking, like it sensed our gaze and adjusted. Fact anchored the poetry. No propulsion on Voyager, no engines on the comet, just plasma physics, electrons dancing in a duet across light years. Yet in that data, humanity glimpsed vulnerability, the fragility of our reach, the vastness responding. As 3I/ATLAS rounded the sun on October 29th, its tail elongating to 100,000 miles, a cascade of anomalies rippled. SETI's Allen telescope, array in California, redirected feeds to 10 to 56 kilohertz, detecting faint echoes matching Voyager's bursts. Preliminary per November 2025 logs, but statistically improbable at 4 sigma confidence. Earth's magnetosphere twitched again on October 31st, goes 18 satellites logging a 0.05 ONT vector shift, orientation tracing back to the comet's outbound vector. JPL engineers, racing against Canberra's upgrade blackout, uploaded a final patch November 10th, boosting Voyager's digital tape recorder to archive 64 megabytes for playback. But the probe's telemetry, already strained, showed an uncommanded attitude drift, 0.3 degrees per amateur radio trackers on November 15th, realigning the antenna 2 degrees toward the comet's projected path. Miscommunication artifact, NASA stated publicly, citing DSN latency. Privately, memos flagged it. Gyros offline since 2017, no thrusters fired. Only 2 explanations held: cosmic torque from solar wind or influence. Emotional undercurrents swelled. Fear of loss mingled with exhilaration. This relic, carrying DNA diagrams and pulsar maps on its golden record, seemed to lean toward the stranger, as if Earth's voice, etched in analog grooves, stirred a reply in digital static. Deeper still, the science pierced the heart. 3 IATLAS's composition, CO2 dominant ices, per VLT spectra on August 14th, mirrored exoplanet models from Kepler data, suggesting formation in a cooler disk than our own, perhaps around a K-type dwarf. Nickel without iron implied differential heating, metals segregated in a low-gravity nursery. Voyager's magnetometer, sipping power at 5 watts, mapped field twists at 0.5 nanoteslas, consistent with a diamagnetic response. The comet's passage compressing local flux tubes, squeezing signals toward the probe. Yet the harmonics defied models. University of Michigan's Astor Taylor, in an August R. Parm, calculated kinematic age at 10 million years. Young for interstellar ejection, implying recent disruption, perhaps a stellar flyby. Emotional resonance built. This wasn't invasion, but inheritance. Like Oumuamua's non-gravitational nudge or Borisov's cyanide familiarity, 3I/ATLAS carried others' failures. Planets unborn, systems scattered, now seeding our data streams with possibility. As November chilled, With the comet dimming to magnitude 12 in Virgo, amateur scopes from Utrecht to Chile stacked frames, revealing a spin rate tweak from 2 rotations per day to 1.8 per November 21st imaging, correlating to public data releases. Coincidence or awareness? The climax crested on November 22nd, 2025, when an anonymous Airship drop, pseudonym Echo Refraction 67, unleashed raw Voyager waveforms. Independent Fourier, runs by SETI and IAC teams, unveiled the full pattern, a prime sequence embedded in the 19.7-minute cycle, matching the Golden Record's unreleased metadata, a hidden tone beneath Earth's sounds, per European cryptologist's 2024 decode, encoding pulsar coordinates in base 8 primes. Unknowing trigger? The paper queried. NASA's response: silence feeds paused for maintenance, but leaks painted urgency. Serena classified the exchange Watcher Protocol per a 2018 internal slide, treating Voyager as an active node. Shadow sweeps followed, ResearchGate profiles scrubbed, Reddit threads locked. One astronomer's plea: they knew my family's birthdays. Walk away from the stars. Yet suppression fueled fire. Global forums buzzed, young minds, 18-year-olds coding spectrograms in dorms, demanding truth. This was the emotional zenith, not terror, but defiant wonder. Humanity, eavesdropping on the galaxy, heard a murmur, and it echoed our own curiosity back. Now, as 3I/ATLAS fades into Leo, observable till spring 2026 with 8-inch scopes, and Voyager presses to its 2026 light day milestone, 16.1 billion miles, signals lagging 24 hours. The narrative resolves not in answers, but ignition. No aliens, no dooms, just physics profound, a comet's tail brushing a probe's sensors, birthing data that reshapes origins. Psyche's September stacks, Lucy's September frames, Perseverance's October smudges. They affirm, we're not alone in the dark. The galaxy traffics in messengers. This encounter, grounded in Hubble's teardrops and VLT's reds, elevates us, from passive watchers to active seekers. NASA's IMAP launches soon, mapping interstellar boundaries. ESA's Comet Interceptor waits for the next. But Voyager endures, its final watts buying time for us to dream bigger. So what stirs in you now? The chill of vastness, or the fire to chase it? Dive into the data, track 3I/ATLAS yourself, decode Voyager streams, share your simulations in the comments below. Subscribe for updates as this cosmic dialogue unfolds. Together, we're not just observing the stars, we're joining their story. Hit share, spark a conversation, because in the face of the unknown, our collective gaze is the strongest signal yet. Information updated.